the last chapter of my career building real time data systems for flight tests in NASA. In that world, we didn't guess, we measured. Now I'm turning that approach to Formula One. The 2026 season is starting, and I admit I'm a rookie. I haven't seen the Netflix show and I don't follow gossip accounts. I wanted to choose a team to support based purely on math. So I scraped 3 years of race telemetry, pit stops, and position changes. I wanted to find anomalies, the fighters, and the most exciting variables on the grid. And the data led me to a conclusion that I have a feeling is going to be a bit controversial. Step 1 was analyzing the tracks. Not all circuits are created equal. I ran a correlation analysis between where the driver starts, the grid position, and where they finish. The tracks at the top of the list, Japan, Belgium, and Italy, have a correlation coefficient of nearly 1. Statistically, this means the race is decided on Saturday. If you have the fastest car in qualifying, you win. From a data perspective, these races are deterministic, in other words, predictable. But look at the bottom. Las Vegas, Miami, Australia, here's where the correlation falls apart. The R squared value drops. This represents chaos, safety cars, crashes, and weather. The data says that if I want to be entertained, these are the weekends I need to clear my schedule for. This is where the variables overwhelm the machine. Next, I looked for strategic stress. I plotted the average number of pit stops per driver for every track on the calendar. Look at Qatar. It's a massive outlier. On average, every driver is stopping more than twice. Zandvoort is close behind. When the pit stop count goes up, the race moves from cockpit to the pit wall. A one-stop race is about tire management. A three-stop race is a math problem. It's about undercut windows and traffic management. I want to root for a team that is smart, not just fast. My model suggests that the winner at Qatar isn't usually the fastest driver, it's the best strategist. These are the tracks where the nerds win. But a fast car is useless without a pilot. To measure driver skill, I looked at the teammate gap. Since teammates drive the same machinery, the difference between them is the purest metric of performance that we have. And this is where the numbers get weird. Look at Red Bull for 2025. This yellow bar represents the gaps between Max Verstappen and his teammates. This is statistically absurd. This is a standard deviation so large it implies a fundamental failure in the second seat. You compare that to McLaren or Ferrari, the gaps are tight. This is a healthy system. But here's my problem. Rooting for McLaren is rooting for efficiency. Rooting for Red Bull is rooting for one guy to dominate while the other guy struggles. Neither of these narratives really appeal to me. So I went looking for a fighter. I plotted positions gained, the net change from start to finish. I used a box plot to visualize the variance. Max and Lando have really small boxes, near zero, and this makes sense. They start at the front and they stay at the front. There's no delta in their race. But look at this anomaly. Look at Lance Stroll. The whiskers on this plot are massive. This indicates high variance. He has races where he qualifies poorly but storms through the field and races where he drops back. Statistically, he is the most volatile variable on the grid. In data science, we usually try to eliminate variance, but in sports, variance is exactly what you want. It means anything can happen. So, let's look at the equation that I've built. I want a team that has to be smart on strategy. I want a driver that provides high variance and action. I want a team that is statistically poised for a breakout. The data points to Aston Martin. They have a high variance driver in Lance Stroll, and I've read that they're bringing in Adrian Newey, the engineer with the highest historical win rate in the sport. So logically, if you combined the best engineer with the most unpredictable driver, that's the most interesting team in the grid. Here's the problem. My numbers don't really have much context. My model says Lance Stroll is the underdog hero of 2026. But when I mention this to F1 fans, they seem to just laugh in my face. So I'm asking you to help me debug this. Is the data lying? Is there a human variable regarding Lance Stroll that I'm missing? Or are you guys just ignoring what the math is clearly saying? Leave a comment and tell me if I made a huge mistake. Subscribe and let me know if the model holds up.